bed while the other crew member releases from the nut side using a standard EVA ratchet wrench or the pistol grip tool. So with that, that concludes my part of the presentation. I'll hand it back to Sandra.
Thank you, and thank you to our briefers for those initial remarks. We will now open it up for questions. As a reminder, if you're on our phone bridge, you can press *1 to submit a question. If you do find your question has already been asked and answered, you can press *2 to remove it. When you are called upon, please state your name, affiliation, and to whom you'd like your question to be directed to. And again, on social media, we will be answering your questions using the hashtag #AskNASA. Our first question comes from Rob Perlman.
Hi, thank you. I have a couple of questions regarding EVA 89. With regards to collecting the microorganism samples, do any special precautions need to be taken before the EVA to clean Laurel's suit, or does the control samples compensate for that? And with regards to Andy riding on the end of the arm being controlled from the ground, are there any additional risks involved in that? What happens in the case of a comm dropout?
So yeah, I think I could take both those. In terms of the vents and where the swab locations are for Laurel, these are all just gases inside of Space Station that are going outside, so there's really no concerns to the contamination on the suit and no real additional precautions that we have to take relative to there. We've looked at all of the possible things that are coming out of those vents, and there's no concerns for her suit. In terms of the second question, for the end of the arm operations robotically, during the entire EVA, Jasmine will actually be a standby on-board robotic operator. So that's how we're mitigating any concerns of a comm dropout during the spacewalk. And we have worked with the crew extensively to make sure that they're ready to take over, again, in case there's any unexpected issues. And we have contingency plans for that. So from a safety perspective, no concerns. We've mitigated the risks relative to comm dropouts.
Thank you, Elias. Our next question comes from Facebook. ARMDC wants to know, what is the temperature at this height during a spacewalk?
Let's see. I can take that one. The external environment around Space Station ranges from -250 Fahrenheit to +250 Fahrenheit. And of course, we get day-night cycles multiple times throughout an EVA, so pretty large swings.
Thanks, Dana. We'll take another question from the phone bridge. This one is from Mark Carreau.
Yes, thank you. This is Mark Carreau from the Houston Chronicle, and I just have two questions. The first one has to do with the robot arm ops. Are they going to be from the ground for both spacewalks or just the first one? And second, could you just generally describe what the future alpha magnetic spectrometer work that you're sort of preparing for with this with this group of spacewalks would entail?
Yep. So for your first question, we are only going to do the test objectives for the ground robotic operations on the first spacewalk. The second spacewalk, we will have Andy operating the arm from onboard the ISS, and I think Dana will take the second part of that question.
Sure. Let's see, for your second question, you're probably aware the alpha magnetic spectrometer is looking at the composition of galactic cosmic rays. The goal with the upgrade is to be able to get more data, so more data throughput and higher accuracy. And so the terms they use with the AMS is instrumentation layers, is the terminology they use. The goal is to build and install a new outer layer and upper layer, which again will give us more data throughput and also higher accuracy. And so there's a series of EVA tasks. This early one is really going to help, as Farouk mentioned, to understand what cabling connections could be used to help connect this future upgrade. And so that's going to inform some of the design solutions in the future. And then there's a series of EVAs to actually install the tracker and to address some of the challenges that come along with heat rejection once we install that. So those are some of the future EVAs.
Thank you. We do have a couple more social media questions, but if you are a reporter on the phone bridge, please press *1 to go ahead and get that question submitted. So our next question comes from Madhausen on Facebook, who wants to know, how do we get such good quality pictures while space station is orbiting the Earth so quickly?
Do you want me to try that one?
So I think, yeah, the pictures that we're having on board the space station, really, we've got a bunch of really nice cameras, and then we've got the cupola window. So from inside of the space station, our astronauts obviously can take amazing photos of our amazing planet. And then outside, when we do spacewalks, they take cameras, similar cameras that are just wrapped in a lot of insulation and protected from the extremities that Dana had mentioned when we're outside the space station, again, to take photos while they're on those spacewalks. Additionally, we've talked about the high-definition camera that we're replacing and upgrading on the outside of space station. So we actually have a collection of high-definition cameras that are constantly streaming to the ground when when we have a signal with the space station that, again, provides just amazing views, really breathtaking views of Earth.
Thank you, Elias. Yes, those photos are gorgeous. Be sure to follow us on social media so that you can see those photos during and after the spacewalk. We do have another question on the phone from Marcia Smith.
Thanks so much. This is Marcia Smith from SpacePolicyOnline.com, and I have two questions. The first one, is this the first time you're collecting microorganisms from the outside of the space station? And if so, what is it about the space station right now, 23 years into its life, that you want to do this? And if not, what have previous studies shown? And separately, I'm curious, Elias mentioned about how putting Andy on the end of the arm and controlling it from the ground was somehow related to gateway operations in the future. And could you just explain that again?
All right, I'll take your first question. The Russians have actually done the most work in the area with microorganisms outside space station. If memory serves, something on the order of maybe 6 or 7 different experiments. I'd have to go and check the actual number. So they have a lot of results, and they've been studying this for a while. There are a lot of publications that are already out there, and so, of course, that's piqued our interest, and we're trying to also understand, based on the extensive knowledge we have of our environment inside, we're curious what may actually move outside with us and what might survive. Part of it's just basic biological curiosity about what can survive in this anaerobic, harsh environment. But the other part of it does have applications to future exploration and just understanding what types of interactions we might have with environments or future planets, for example, and things that we could end up bringing with us.
And then for the second part of your question, how does this apply to the Gateway program? So I think everyone's familiar. We have a Gateway program currently in development. We're in requirements. We are designing this space station around the moon that will enable us to be a staging point for our lunar lander and Artemis programs to go to the South Pole. That will have a robotic arm similar to what the ISS has currently. And really, this new operation of having the ground control of the arm on board the space station is just a different way to interface through software and applications that may look more similar to what Gateway is doing. So really, this is just providing another way for us to operate the arm from the ground during a spacewalk, which will help inform those requirements and ops concept development that's going on with our Gateway program.
Thank you. And we do have another social media question. Steen Reese on Facebook wants to know if astronauts are exposed to more radiation while on a spacewalk than while inside the International Space Station.
Okay, I can take that one. They are exposed to a bit more radiation when they're outside doing a spacewalk. Of course, the suit does offer some protections, but inside space station, we have a lot of dense metallic equipment, which is a great barrier to radiation. The way our modules are designed, the equipment is located on the outer portions of the modules, and that helps offer additional protections to the crew from the radiation environment.
Thank you, Dana. We do have another media question from Robert Perlman.
Again, about EVA 89. About 16 minutes after Andy and Laurel exit or begin the spacewalk, the psych launch is scheduled. Do you know if the space station is going to be, at this point, do you know if the space station is going to be within view of Florida and whether they might have an opportunity to see the launch while on the EVA?
Yes, I don't actually have that answer, but we can get back to you and see if the space station will be in view of Cape Canaveral during that launch. But good question.
Thanks, Robert. We'll follow up with you on that one. Good question. So that is actually all of the social media questions that we have for today, as well as all of the questions that reporters submitted online. So thank you all so much for joining us for today's briefing, and thank you to our briefers for being here as well. I do hope that you'll tune into NASA TV to watch the series of spacewalks. The first spacewalk on October 12th is scheduled to begin at 10 a.m. Eastern and last about 6 hours. NASA TV coverage will begin at 8:30 a.m. Eastern for the first spacewalk. And the second spacewalk on October 20th will begin at 7:30 a.m. Eastern and last approximately 6.5 hours. NASA TV coverage will begin at 6 a.m. Eastern for that spacewalk. So thanks again for joining us. That will wrap up today's briefing.